Good afternoon, class. We are looking at exam 3 review, which will cover from section 3.5, the second part, 3.7, 3.8, 4.1, and 4.2. Differentiation formulas. Hopefully everybody's comfortable with those. And the concept of differentials and linearization, which in short is simply finding a tangent line. Logarithmic properties, which will help us with differentiation involving logs. And as long as we can see this, that whether we have a logarithmic format or exponential format, they have the same base, the same exponent, and we can go from one format to the next. All of these properties will be easily understood. For example, log 1 with any base is 0 because b to the power of 0 is 1. Log b base b is 1, meaning if the base and argument are the same, b to the power of 1 is b, is to refer to the fact that logarithmic and exponential functions are inverse functions. Product rule, quotient rule, power rule, change of base formula, and in this case the base is e, natural log. In this case the base is 10, common log. We want to use implicit differentiation to find dy dx or y prime. So on the left side, 4 becomes the coefficient. We write the parentheses to the power of 3. We subtract 1 from it. And then the derivative of the inside, 2x gives us 2 and y gives us y prime or dy dx. On the right side, x gives us 1 minus 2y becomes minus 2y prime. And we are done with calculus. This is the only calculus step, everybody. Now we are solving for y prime using our algebraic techniques. So remember, we want to solve for y prime. You can distribute, but we want to do it wisely so it doesn't take too long. Understand, I can multiply this by 2, and it becomes 8 times 2x plus y cubed. Then I can multiply this one by y prime. So I can write this expression times y prime, and the right side doesn't change. So again, 2 times this expression gives us this one, 8 times this expression, and then 4 times the expression times y prime. We are solving for y prime, so we're going to move things such that everything involving y prime comes to the same side. Meaning, I'm going to move this one to this side, and it becomes plus 2y, and I'm going to move this one to the other side, and it takes a negative sign. On the left side, we are interested in solving for y prime, which means we are going to factor out y prime. When we factor out y prime, we get this piece, 4 times 2x plus y cubed for the first one, and we get 2 for the next one, and the right side doesn't change. So what is y prime or dy dx? It's the right side. All you have to do divided by the brackets in blue. So whether you want to call it dy dx or y prime makes no difference. Dy dx or y prime equals 1 minus 8 times 2x plus y cubed over 4 times 2x plus y quantity cubed plus 2. Now I'm going to use implicit differentiation for this expression to find y prime or dy dx. So let's start with the first expression. Sine becomes cosine with the same argument. So cosine y. And then y, remember it's a function of x, so it's y prime or dy dx. I'm going to put a raised dot between these two expressions, 2x cubed being multiplied by y squared, meaning 2x cubed gives us 6x squared times y squared. I'm using the product rule. Plus y squared gives me 2y y prime or dy dx times the first piece 2x cubed. The right side is a number. Any number ends up being a 0 when you differentiate. So we are solving for y prime or dy dx. Let's rewrite this as cosine y dy dx plus 6x squared y squared. Let's put these two together, make it 4x cubed y dy dx. And we are going to move this to the right, so it becomes negative. And on the left side, we factor out the dy dx, which gives us cosine y plus 4x cubed y. So these two pieces, we factor out dy dx, and this piece moves, becomes negative. So dy dx or y prime is the right side divided by the parentheses. Dy dx is the right side minus 6x squared y squared over the parentheses, which is cosine y plus 4x cubed y. We want to find an equation of the tangent line for this function at this pair. And to come up with the equation of a tangent line, we need two things. We need a pair x comma y, we have it. We also need the slope, which means we have to differentiate, and we have to differentiate implicitly. So let's do them one by one. First, x squared gives you 2x. Then 2xy, again, let me put a raised dot in between. Meaning you're multiplying 2x times y. So 2x gives you 2 times y, and y gives you either y prime or dy dx times 2x. So that's the second piece. Minus y squared is minus 2y prime plus x plus 1. Any number results in 0. Minus 2y prime plus x, that means plus 1, and a number results in 0. And we are done with calculus part. All we have to do, solve for y prime, which means we are moving this part to the right, becomes minus 2x minus 2y. We are moving this part, becomes negative 1. So we move everything to the right that does not involve y prime. And now on the left side, we can factor the y prime out. Gives us y prime times 2x minus 2y. And we divide everything by 2x minus 2y. So y prime or dy dx becomes minus 2x minus 2y minus 1 over 2x minus 2y. Now we are going to plug in the pair 1, comma 2. When we plug in, we get 7/2. So let's quickly show everybody. So minus 2 times x, which is 1, minus 2 times y, which is 2, minus 1. And the denominator is 2 times x, 2 times 1, minus 2 times 2. So the numerator is negative 7, the denominator is negative 2, so it becomes a positive 7/2. Y minus y1 equals m times x minus x of 1. This is the point slope. Remember the tangent line, just use the point slope. Therefore, y minus 2 equals 7/2 times x minus 1. And the right side is 7/2 x minus 7/2. And moving the negative 2, and we're making it positive 2. And this is the final answer. Y equals 7/2 x minus 3/2. And you can double check by plugging in the pair 1, comma 2. We want to differentiate this again. We are using implicit differentiation. We want to find dy dt. It's important to pay attention to this, and right away it tells us t is the independent variable, meaning not only the derivative of y is dy dt, the derivative of x is no longer 1, it's dx dt. And as you can see, dx dt is given as 2. So right away, let's put a raised dot in between here so we can use the product rule on this. So put a raised dot between x and e to the power of y. So let's differentiate this. X gives you dx dt times e to the power of y plus e to the power of y. Remember, exponential, the derivative is always itself, and then you look further. So e to the power of y itself times, by the chain rule, the derivative of y, which is dy dt, and by the product rule times x. So again, e to the power of y gives you this part, e to the power of y dy dt, and then times x. Plus 4x gives us plus 4 dx dt. And the right side is y cubed, 3y squared dy dt. And again, we are done with calculus. We are going to plug in, which means we are going to replace whatever is given to us. Dx dt, replace it with 2. E to the power of y, replace the y with 0 plus e to the power of 0 dy dt, missing, x negative 1 plus 4 dx dt is 8, right side 3, y is 0, square it, dy dt is missing. So we just plug in everybody. And let's observe. We know anything to the power of 0 is 1. And the right side, because it's being multiplied by 0, is 0. So what you see on the left side is 2 minus dy dt plus 8, which means is to add up to 10. So dy dt is 10. We want to differentiate this. We notice it's 2x times ln of 3x squared, although you can simplify this, but when you have to use the product rule, it's better to keep it this way on a normal basis. So let me put a raised dot in between, which means you're multiplying 2x by ln x squared. Therefore, we use the product rule f prime g plus g prime f. So the derivative of 2x is 2 times ln 3x squared plus, let's see what's the derivative of ln 3x squared. First, we flip this over, 1 over 3x squared. Then we multiplied by the derivative of that g prime of x by the chain rule times 6x. And then we multiply by 2x by the product rule. In other words, if we assume this is f, this is g, this is f prime g, this is g prime f. We are looking at the product. So we just rewrite this. This one is just 2 ln 3x squared plus 4. And this one, I hope you see that this is 12x squared divided by 3x squared is simply 4. So this whole thing simplifies to 4. We want to differentiate this, and again, we can use it just the way it is, which means we have to flip this over and then multiply by its derivative using the quotient rule. But the best course of action is to cut this into pieces. This is ln of the top minus ln of the bottom. Ln of the top, ln of 5x is ln 5 plus ln x minus ln of the bottom, which is ln of x squared plus 5. So ln of the top minus ln of the bottom. All right. Now let's differentiate. Ln 5 is a number. The answer is 0. Ln x is 1 over x minus ln of x squared plus 5. Flip this over, 1 over x squared plus 5. And then by the chain rule times the derivative of the parentheses or the argument of natural log, which makes it 2x times 2x. And we are done with calculus. Let's put them together by finding LCD, the least common denominator, which is x times x squared plus 5. X times x squared plus 5. And then 1 times x squared plus 5 minus 2x. This is 2x minus 2x times x. So we have this. And the numerator, we are going to write it as x squared plus 5 minus 2x squared. We can combine these two into minus x squared. So the final result is minus x squared plus 5 over x times x squared plus 5. We want to differentiate g of x equals log of 9 minus x cubed to the power of 4. First, let's simplify the log. Let's decompose the log by putting the 4 in front. The power rule. Now we want to differentiate. To differentiate this first, this 4 is a multiplier and we're going to keep it. Then to differentiate the log, first flip this over. So the argument, so it's 4 times 1 over 9 minus x cubed. Then by the chain rule, I need the derivative of the argument of log, which is negative 3x squared. And then since the base is not e, I need 1 over ln b. And since the base is missing, that means the base must be 10, 1 over ln 10. I'm done. I'm going to just rewrite this. So this is the end of calculus. So what's in the numerator? 4, 1, negative 3x squared, and again 1. That gives us negative 12x squared. And 9 minus x cubed times ln 10 remains in the denominator. And that's the final answer. Y is given as, or f of x as x squared over x minus 8. We want dy. We want dy and delta y when x is 4. And dx or delta x is 0.2. We want to evaluate. So the very first thing is, anytime they ask you for the differential dy, the very first thing is for you to find y prime or f prime of x or dy dx, differentiate. And to differentiate, we need to use the quotient rule. So if you assume this is f over g, you need f prime g minus g prime f over g squared, which means I want to differentiate this. The derivative of the top is 2x times the bottom minus the bottom gives me 1 times the top x squared over the bottom squared. So that's the differentiation using the quotient rule. All I have to do is simplify the numerator first. So let me do that. This is 2x squared minus 16x minus x squared. I can put these two together as x squared. And dy is the same expression times dx. Now the rest is elementary algebra because we're going to plug in. We are going to plug in x equals 4. Dx or delta x is 0.2. So we plug in. Of course, 4 squared is 16. 16 times 4 is 64. 4 minus is minus 8 is negative 4 squared becomes positive 16. The numerator is negative 48. And you divide it by 16, you get minus 3 times 0.2 is minus 0.6. So that's dy. What is delta y? F of x plus delta x minus f of x, so f of 4.2 minus f of 4, which means plug in 4.2 into the original function, plug in 4 into the original function, look at their difference. You can use a calculator to do the math. So this is 4.2 squared over 4.2 minus 8 minus 4 squared over 4 minus 8. You do the math and you end up with negative 0.6421, pretty close to negative 0.6. And it would have been even closer if delta x or dx would be much smaller in a matter of comparison to the choice of x. So elementary algebra, plug in the value. We want to use differentials to approximate the cube root of 63.5. And to use the differentials, we need two things. First, we need a function. And all you have to just read this. What is the operation we are doing? Cube root of a number. So that function f of x is a cube root of x. Then we want to choose a number x that is close to this number, and we can easily find the cube root. Okay, so first the function is cube root of x, and then we want a number very close to that. Can anybody give me a number close to that, such that we know the cube root of it? The closest number would be 64, because we are supposed to know the cube root of 64 is 4. And delta x or dx is the difference between these two numbers. And remember, this is x, so we have to subtract 64 from the number we want. So it's important to know that delta x is negative. The reason why, because this is the number we can easily handle. We are interested in cube root of 63.5, so it's going to be smaller than 4. That's why dx becomes negative. If it were, let's say, 65, then delta x or dx would be plus 1. We are adding a number. So you want to be very careful with the sign. So if f of x is cube root of x, you can change it to x to the power 1/3. And you know how to differentiate that. 1/3 x to the power of negative 2/3. So you can differentiate this easily. So this is f prime of x. Now we can rewrite this by taking it down x to the power of positive 2/3, or cube root of x to the second power. So that's f prime, rewriting it with a positive exponent. And dy is the same thing times dx. So if I multiply this one by dx, that means I put the dx at top, then it's dy. Therefore, f of x plus delta x can be approximated by f of x plus dy, and f of x is the cube root of x. Dy is this expression dx over 3 cube root of x quantity squared. Now, all you have to do, replace the x with 64. Same thing here. And then dx with negative 0.5. When we do that, of course, this is 4. This is 4. So I want to discuss this one. So what you're looking at is negative 0.5 divided by, and you square the 4, 16 times 3 is 48. And I hope you see that minus 0.5, like minus 1/2. So it becomes minus 1/2 times 48. And that's how we get negative 1/96. So 4 minus 1/96, that means 3/95/96. And we can use decimals with a bunch of decimals, in this case, 1, 2, 3, 4, 5, 6 decimals. So this is using differential to get to the answer. For this part, you don't even need a calculator. Then if you want to do the approximation. The second method using the differential is equivalent to linearization. And linearization simply means tangent line, everybody. And tangent line, you don't have to memorize any of this. Just use the point slope. Y minus y1 is m times x minus x sub 1, which means I need two things. I need a pair. Well, x is 64. What is y? Cube root of that, which makes it 4. And what is the slope? Remember, f prime of x is this. So if I replace the x with 64, remember this becomes 4. Square it, 16 times 3, 48. So 1/48. So that's your slope. So here's your pair, here's your slope. Y minus y1 equals m times x minus x sub 1. So y minus 4 equals 1/48 x minus 64. If you do the math, y or L of x is this. And now all you have to do, replace the x with 63.5. It must give you the same answer, and it will. Again, do you have to do both ways? Absolutely not. But you need to understand both of them will result in the same thing. And linearization, simply put, means find the tangent line. We want to find the absolute max and mean. This function is a polynomial. What is the degree? 2 times 3. So it's a polynomial of degree 6. The domain is all real numbers. Therefore, it's also continuous in the given interval of -1 to 2. So it's a polynomial of degree 6. Why is it degree 6? Because this is x squared. We are raising it to the third power. So it's continuous from negative to positive infinity, or you can say the domain is negative to positive infinity. Therefore, it's continuous in the given interval. So let's differentiate because we want to find CPs. So f prime of x is 3 times the same thing to the power of 2 by the chain rule times the derivative of the parentheses, which is 2x. And we're going to set this equal to 0. So when you set this equal to 0, this gives you 0. By the way, if you want, you can simplify it and write it as 6x times x squared minus 1. You set this equal to 0. X gives you 0. X squared minus 1 equal to 0 gives you x equals plus minus 1. There are 3 answers. Let's check it out. Is -1 in between? Well, it's one of the endpoints. We have to use it anyways. Is +1 in between? Yes. Is 0 in between? Yes. So let's evaluate the expression at -1, +1, 0, 2, all of the above. And this is our elementary algebra. Okay. For example, if you plug in -1, I hope you realize you get +1 because you're squaring it with -1, it becomes 0 cubed, which is 0. The same thing with 1. When you plug in 1, you get 1 minus 1, 0, because it's 1 squared. If you plug in 0, you get negative 1. Cube it. Negative 1 cube gives you negative 1. If you plug in 2, 2 squared is 4. 4 minus 1 is 3. 3 cubed is 27. So the largest number is 27. That's your absolute max at this pair. The smallest is negative 1. That's your absolute mean at this pair. And again, the way you write it is the way they want you to write it. So you want to pay attention to the way they ask you to write. Could somebody read this, please?
I can read it.
Please.
A small rock is dropped into a lake. Circular ripples spread over the surface with the radius of each circle increasing at a rate of 3/2 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet.
Excellent, thanks. So we are dealing with the circles and we need to know the following relationships. Area is pi r squared. Diameter is 2 times the radius. Circumference is 2 pi r. What we want is just the area. We don't want all of them, but we should know all of this. We want to find the rate at which the area of a circle is changing when the radius is 4 feet. So first, we need this piece of information, a equals pi r squared. And then what is changing? The radius of each circle increasing at a rate of 3/2 feet per second. That means the RDT is 3/2 feet per second. What are we looking for? The rate at which the area is changing. We want dAdt. When R is 4 feet. So this is the translation of the question. A equals pi r squared. We want dRdt. We know dRdt is 3/2 feet per second. We want to find dAdt at the precise moment where the radius is given as 4. And so we want to differentiate this. A is pi r squared. dAdt is pi times 2r dRdt. So dAdt is pi is a number, and then r squared is 2r dRdt. And when we put them together, is 2 pi r dRdt. And now we can replace the r with 4 or 4 feet, and the rdt with 3/2 or 3/2 feet per second. Remember, whatever we do to numbers, we do to units, and the ADT will have the same unit as the units of the area over the units of time. And as you can see here, this is 4 feet, this is 3/2 feet per second. That's why when you're done, the units would be square feet per second, and it does work. So these two cancels out these two. We have 4 pi times 3 is 12 pi square feet per second. And we can use a calculator, not 3.14, a calculator with more decimals. And that gives us 37.6991 square feet per second. Could somebody read this, please? Anybody would like to read this question for us, please?
I will.
Please.
A spherical balloon is inflating using 8 centimeters cubed of air per minute. At the moment when the radius of the balloon is 20 centimeters, how fast is the radius decreasing? Hence, velocity equals and volume equals 4/3 pi r radius.
Thank you so much. So the reason I chose that, I want to make sure that everybody understands this refers to a negative sign. So a spherical balloon is deflating at that. We have to know the volume is 4/3 pi r cubed because we want to relate the volume to the radius. So what is given? First and foremost, we should know the volume is 4/3 pi r cubed. But we should know dV dt is -8 cubic centimeters per minute. And we are interested in finding the r dt at the moment when r is 20 centimeters. So here's the translation. Volume is 4/3 pi r cubed. That's a piece of information from geometry. Given dV dt is -8 cubic centimeters per minute, we want to find dr dt when r is 20 centimeters. So let's differentiate this. Let's find dV dt. dV dt is 4/3 pi is a number, so 4/3 pi times, now r cubed, we're going to differentiate that into 3r squared dr dt. So we have 4 pi r squared dr dt. We plug in, replacing the r with 20 or 20 centimeters because the units will work out. Left side is -8 or -8 cubic centimeters per minute. We have 4 pi over times 20 squared dr dt. Twenty squared is 400. So we divide -8 by 4 pi times 400. 4 pi times 400 is 1600 pi. And so we can get rid of the 8. And 1600 changes to 200. So negative 1/200 pi centimeters per minute. It's extremely important to know the units work out, dr dt, the units of the radius over the units of time. Now, if you want to change the pi, you can use a calculator, which gives you 3.14159, and it continues indefinitely. So negative 0.001592 centimeters per minute. That means as the balloon is deflating, the radius is also decreasing. When you mention decreasing, you don't write the negative. Right now, we have to write the negative side. When you graph this function, f of x is minus x cubed plus x squared plus x. And if you look at the leading term, you know it looks like minus x cubed as far as the end behavior is concerned. But in any event, to solve this, first we want to find the intercepts. Let's factor out what we can, in this case, minus x. And so, of course, x equals 0. And that means 0, 0, that's 1 pair. Now, we set this one equal to 0, and this can't be factored. We use the quadratic formula. So I'm going to quickly show you. In this case, a is 1, b is -1, c is -1. So let me. So if I want to set this equal to 0, using the quadratic formula, a is 1, b is -1, c is -1. We go through that. Minus b plus minus a squared of b squared minus 4ac over 2a. I'm assuming everybody is very comfortable with that. So minus b minus -1 plus minus the square root of b squared minus 1 quantity squared minus 4 times a, which is 1c, which is -1/2. As you can see, this is +1. As you can see, this one negative and negative +4, they add up to 5. And so we have the following intercepts: 0, 0, right from here. And then this means 1 plus square root of 5 over 2 comma 0, 1 minus square root of 5 over 2 comma 0. So we have 3 intercepts. The next step is to find CPs, and to do so, we have to find f prime of x, which is minus 3x squared plus 2x plus 1. We are going to set this equal to 0. To do that, first let's factor out the negative sign. The factoring is not too bad because 3 is a prime number and 1 has to be 1 and 1 of them negative. So when you factor it, this is what you get. Notice the middle term of minus 3x here plus x, it gives you minus 2x. So when you set this one equal to 0, x becomes 1. So f prime equals 0, x equals 1, x equals negative 1/3. We are interested in finding local extrema, intervals of increasing, decreasing. We have to do the first derivative test. That means we put a sine graph, and on the sine graph, x at -1/3 f prime is 0, at 1 f prime is 0, and then we pick up TPs. Let me tell you how the TPs work, or test points. If we were to pick a test point, obviously over here would be 0 between the two numbers. One is negative, one is positive. This one would be negative, this one may be positive too. And it is easiest to use the 0. As you can see, you can plug in 0 into this or into this. Either way gives you +1. And that makes it positive because f prime is of degree 2 and it has 2 solutions, then they will alternate. So if this is +1, this is negative, this is negative. If you have any doubts, put the -1 either into this or this one. And you can see, for example, if you put it here, this becomes negative, this becomes negative, and because of the negative in front, negative times negative makes it negative. You can try to. And what it means is, negative means decreasing here, positive means increasing here, negative means decreasing here. So it's decreasing becomes increasing. So this is a location of a local mean, and increasing here, decreasing here, this is the location of a local max. Both numbers have to go to the original function to figure out the y coordinates. And it is decreasing from -infinity to -1/3, union 1 to infinity. It's increasing in between the two numbers, -1/3 to 1. So if you plug in 1, actually, it's very easy to figure out, makes this one negative, this one positive, this one 1. So at 1, if you plug in 1, you get 1. So local max equals 1 at 1, 1. But what is local mean? You have to plug in -1/3 and evaluate it. So local max is 1, because just plug in 1 very fast, you can see the answer. If you plug in -1/3 and evaluate it, so we have a minus. -1/3 to the power of 3 is -1/27. With this negative becomes +1/27. Plus -1/3 squared makes it +1/9, and this is -1/3. And I'm assuming we can all add up, and we get -5/27. So local mean is -5/27 with this pair. Again, I mentioned it's increasing from -1/3 to 1 and decreasing otherwise. So the first derivative test gives us a lot of information. It gives us intervals of increasing, decreasing, local extrema. The next step is to find the inflection points. That means we have to find f double prime and set it equal to 0. We already know what our intercepts are max and mean, f of x, f prime of x. So we find f double prime, which becomes minus 6x plus 2. And when you set this equal to 0, I hope everybody can see just the answer is 1/3. It's easy to see that. So we have to do the sign graph for f double prime. When we do that, at 1/3 f double prime is 0. To the left of 1/3, for example, 0, if you pick 0 and you put it into f double prime, again, TP, I can put a 0 here and I can put a 1 here. Test point. If you plug in 0, it makes this positive 2. If you plug in 1, minus 6 and positive 2 makes it negative 4. Positive, concave up from negative infinity to 1/3, negative concave down from 1/3 to infinity. So we have concave down from 1/3 to infinity, concave up from negative infinity to 1/3. Therefore, it makes x equals 1/3 the inflection point. We must go back to the original function, replace the x with 1/3 to find the y coordinate of the inflection point. We do that. So minus 1/3 to the power of 3 is positive 1/27. This makes it negative. Plus 1/9 plus 1/3, and we can add them up to 11/27. So the IP, or inflection point, has the coordinates x equals 1/3, y equals 11/27. So let's put all of them together into a little summary. So x-intercept is located at 0, 0. The next one, 1 minus square root of 5/2. Why are we changing it to negative 0.62? Because we want to graph it. And this one, 1.620, again, for the graphing. Maximum takes place at 1, 1. IP address, we're going to change those fractions to decimals, about 0.3 and 0.4. Minimum takes place at negative 1/3 and negative 5/27. Again, we change it to decimal notation. It makes it easier. For the graph, let's plug in. So this is 0, 0. Minus 0.620. About 1.620. 1, 1. And we put an arrow because we know it's a local max. 1/3 11/27 is about 0.3, 0.4. That's an inflection point. Minimum takes place at this pair, and we put an arrow. And we know the end behavior, right? Because looking like minus x cubed, so you can graph it. As you can see from the graph, the function is decreasing here, increasing here, decreasing here, and it's concave up here, concave down here, local mean, local max. Everything is shown right here with details.